Deciding first-order rewritability of LTL ontology-mediated queries by Vladislav Ryzhikov, Yury, Savateev, and Michael Zakharyaschev. We are interested in ontology-based data access over qualitative temporal data. As the base of our system, we use linear temporal logic. An LTL ontology is a set of axioms. And we receive data in form of temporal A boxes, and we query them with LTL formulas. We treat queries as Boolean under open-world semantics, so the certain answer to a query is yes if the formula is true somewhere in every model. Inspired by DL Lite, we classify our ontologies by the shape of their axioms, so we can talk about core, chrome, and horn ontologies. We also can classify queries. They can be atomic, positive, without certain operators, etc. In classical OBDA, we rely on first-order rewritability, so we can reduce OMQ answering in open-world semantics to a database query evaluation closed-world semantics. In our context, every OMQ is rewritable into formula in first-order logic enhanced by relational primitive recursion, or a monadic second-order formula, which gives NC1 data complexity. So the non-uniform rewritability problem is the following. Given an OMQ, can it be rewritten to a formula in one of the following first-order systems presented on the slide? This determines the data complexity of OMQ answering as shown. For example, this OMQ is rewritable to a first order with less than, because if an A box has the certain answer yes for this query, it must have a place where D is true and either C is true, or there is a later place where A is true and everywhere in between B is true. This is expressible by this first order formula with only less than. The answer to this OMQ is yes only if either there is a place where C is true, or there is A and B even distance apart, or there are two of the same letter odd distance apart. Since first-order logic with less than cannot distinguish between odd and even, this OMQ is not rewritable into it. It requires first order with equivalence. So here are our complexity results for the rewritability problem for different types of OMQs and first-order systems. For the most general case of OMQs, the complexity is X space. The same complexity is reached even if we limit ourselves to horn ontologies with atomic queries, or to chrome ontologies with positive existential queries. The main proof goes like this. We interpret A boxes as words in a finite alphabet. Turns out that good A boxes form a regular language for any OMQ. The rewritability of OMQ into a first-order system turns out to be the same as definability in the same system of the corresponding language. There are algebraic criteria for definability of regular languages in terms of transitional monoids of their automata. Checking this criteria is p-space complete or can be done in p-space in the size of the automaton. Automata corresponding to OMQs have exponential size, which gives us X-space bound for the rewritability problem. Smaller bounds for more limited classes of OMQs are done by different automata theoretic techniques. In the future work, we would like to extend this non-uniform analysis to DL Lite and schema.org. Thank you.